In this video, we're going to be using Desmos to graph each of the following equations and describe the differences that occur from graphing the f of x to the g of x. And a special note is that our f of x are all the parent functions for the absolute value function, which is the absolute value of x. So we're going to begin by graphing that in Desmos first. And so here we see our absolute value function in red, right? The absolute value function of x. So we're going to go ahead and now we're going to start entering in each of these. So we're going to start with letter A, and it says that our g of x, right, our g of x is going to equal the absolute value of x minus 2. And so when we put that in, we're going to see the change that occurs. Now notice how the green graph has changed from the red graph. It's still the V shape, it's still the same size, it's just moved to the right 2 places. And so that's what we want to go ahead and write down here, because it has asked us to describe the difference that has occurred. So here we've moved to the right 2 places. So let's go ahead and let's do letter B. So we'll move that, get rid of that one. And then we're going to do our g of x equals our absolute value of x plus 7. Now notice how this graph has changed. It's the same size, the same shape, but now it has moved up 7. So here it's gone up 7 units. Let's take a look at letter C. Let's do that one. So we'll close this graph out. So we're going to set up that our new g of x is going to equal a negative absolute value of x. And take a look at how this graph has changed. Here we see that our graph has shifted down. So right here we have our parent function, and this function that we've just typed in looks like the exact same thing, it's just upside down. We call this a reflection across the x-axis. And so for our description, we're going to go ahead and write that. It's a reflection. So it reflects across the x-axis. Let's take a look at letter D and how that might change. So here for our g of x, we have the absolute value of 1/2 times x. Now notice what has happened to our graph. It's still a V, but now it's gotten wider, right? It's gotten wider. So we're going to go ahead and write down wider by 1/2. It's gotten wider by 1/2. Now, as you get into some higher math classes, they're going to have names for that. And this is called a horizontal stretch by 1/2. But you can go ahead and just write down wider by 1/2 for now. Although we should point out that when it's on the inside with the absolute value symbol, we generally say that it's wider by the reciprocal of that number. So really what we should be saying here is that this is wider by 2 because the 1/2 is on the inside with the absolute value symbol and the x. Let's go ahead and let's take a look at E. Now E is very similar to letter A, and remember we said that that moved to the right too, right? In fact, let's go ahead and let's write that in there. So here we're going to have the absolute value of x plus, now which way do you think this might go? When we put our 3 in, we see that it moved to the left 3 places. Isn't that interesting that when we had a minus, it moved to the right, but when we had a plus, it moved to the left? That's something to note, that will happen every time. Let's move on to letter G. So for letter G, we have that our g of x, oops, try that again, that our g of x equals the absolute value of x minus 1. So my question to you is, which direction do you think this is going to go? Because it looks an awful lot like letter B. Did you say down? You were right. It moved down 1 unit. So we'll write down 1. Let's make that look like a D. There we go. Down 1 unit. Let's go ahead and let's plug in letter H. Now notice that H looks a lot like C, which is that small difference that that negative sign is on the outside of the absolute value instead of on the inside. So what do you think this might look like? Let's see. Negative absolute value of x and notice that we have that reflection across the x-axis, which makes me realize that I graphed letter C incorrectly. So for H, it is a reflection across the x-axis, and how I can check to make sure did I graph C right or not is if I plug that in right now, like I can give myself another one, we'll call it H of x, or let's call it C of x because we're doing letter C. If I plug that in correctly and I put the absolute value and then the negative x, you're going to see that what it did was it just laid right on top of my red line, right? So if I do only letter C, I see just that piece. That's actually what we call a reflection in the y-axis. So we need to make that adjustment really fast for letter C. That is a reflection in the y-axis. So it's kind of like it just turns around. So again, here's the answer for letter C, is that reflection in the y-axis. So that twist around the y-axis. And for letter H, we have the g of x is the negative on the outside for that, which means it reflects across the x-axis going down. Let's take a look at letter I. So here we're going to be multiplying by a 4, but it's not on the inside with the x. So which direction do we think this might get? So 4 times the absolute value of x. And look at that. Instead of getting wider, it got narrower. And so we're going to go ahead and we're going to write down narrower by 4. So this got narrower by a value of 4. And in an upper math class, this would be called a vertical stretch because you're pulling it up by a value of 4. So we've got 2 more to do. So let's go ahead and do these really quick. So for letter J, when we plug that in, we have the absolute value of 3x. Now look at that. This one isn't quite as skinny as what we just did, but it's still narrower than letter D, even though our number was on the inside. So here we're able to say that this is narrow by a value, and because our 3 is on the inside, we're going to take its reciprocal, which is going to be 1/3. So it's narrow by a factor of 1/3. Let's go ahead and do letter K. So K is kind of like letter I, except now instead of having a whole number, we have a fraction. What do you think might happen if I'm using a 1/5 on the outside as opposed to that positive 4? So I'm going to plug that in. Did you say it was going to get wider? Because if you did, you were right. So here we see a vertical shrink, so we're kind of pulling the graph down, that red graph down, to get to where our green graph is. So again, this is going to be, we can just say that it is wider by 1/5. And so that's how you can kind of see some patterns kind of emerging from different transformations in our equation and how those relate to our graphs.